Okay. Yeah. Jane and John. All right. So this is what we know about Jane and John. Joe, we've done this earlier today. Jane's less massive than John. They're on a frictionless surface, or assumed frictionless. They're 10 meters apart. Jane has this much acceleration. Without doing any problem solving, let's apply some conceptual thinking, conceptual understanding. Should John's acceleration be greater than Jane's, same as Jane's, or less than Jane's, and why? I want everybody to think about that for a second. I'm going to call them. Come up with John's acceleration being greater than, less than, or equal to, and why. Let me hear from Emily. Emily, should John's acceleration be more than, less than, or same as?
The one problem that we confused on.
Oh, okay. All right, that's fine. No, you asked about this and you were going to answer that question. So tell me, what is it?
His will be less than hers because their force would be the same, and his mass is greater.
Yeah. How do we know the force is going to be the same?
Equal and opposite.
Equal and opposite. Newton's third law, right? Force he applies on her is equal to the force she applies on him. And then you said he has more mass, so less acceleration would be the same force. That's great. That's the application of Newton's second law.
So Jane, So Jane or John?
John, I'm sorry. John has less acceleration because they have the same force. Right? His force on her is equal and opposite to her force on him. That's Newton's third law. To figure out what the actual force is, right? We just take her mass times her acceleration, and we find it to be 46 newtons. Well, from that, we know that the force on him is 46 newtons, but in the opposite direction. Right? So it's a negative 46 newtons. He's 60 kilograms, so we can solve for his acceleration. And we find that it's negative 0.77. Since I took the time to think about the problem, I can have some confidence in my answer. Because it's less acceleration than hers. I already figured it should be. And it's not that much less because their masses aren't that much different. In fact, they're, what, about 20% different. And so this should be about 20% different as well. Okay, we're getting somewhere. So we know his acceleration, we know hers acceleration, and they also want us to find out where are they going to meet. Where are they going to be when they smack together? Well, here you just need to set up simultaneous equations. Okay. Her position, she started out at 0. And she's going to accelerate at the rate that was given for an amount of time. This is our relationship. He started out 10 meters away. And he's going to be accelerating toward her. When I substitute this in here, it'll be a negative acceleration. Okay. So if I solve this simultaneously, I'm going to find out where they are. Tip for you guys using your graphing calculators is, this is your y1 and your y2 on your graph. Right? You would enter this in as 1/2 of 0.92 times x squared. And this would be 10 minus or plus 1/2 of negative 0.77 x squared. And you'll find out where those two things meet.
Oh, the intersection.
Yeah. Because right, x1 is her position, x2 is his position. We want to know when they're at the same position. We want to know when x1 and x2 are the same.
Legit.
If you put it in your calculator just like I told you to do, hold on, it's right here. You'll see you've got these two parabolas. You just find the intersection. The thing you need to be careful about is x on this graph, remember, was your time. So they don't meet at 3.44 meters. They meet after 3.44 seconds. Y was their position on your graph, so they met at 5.44 meters from Jane. And then you can ask yourself, does that make sense? She's accelerating faster than he is, and they meet closer to him. Sure, that makes sense, right? The one that's going faster is going to go further. Cool. Any other preguntas?
16.
16?
Did
we just do
No, no, I'm not
Yeah, we
talking.
did.
Oh, okay.
Can you have your calculator?
Any other preguntas?
Well, sorry, future me.
You use your calculator.
Choose that. Absolutely.
That's how you guys want to do it.
Okay.
Well, sorry, future me, but you're out of storage.